The last thing that we're going to do is look at solving equations using properties of logarithms. So the property that we're really going to need for this is this one, log base x of a times b equals log base x of a plus log base x of b. And the reason that I say that is when I look at my original problem, I've got two logs over here separated by addition. Over here, I have two logs separated by addition, which then leads me to believe that I'm going to need to use that property to make it multiplication. So let's do that. Log base 6 of x times x minus 9 equals 2. We can simplify that even more. We can distribute log base 6 of x squared minus 9x equals 2. From here, it's not always known where do I go, but we do know that we like working in exponential. So if you don't know how to deal with something in terms of a log, you might want to think about changing it to exponential. And if I change it to exponential, I'm going to have 6 as my base, 2 as my exponent, and that's going to equal x squared minus 9x. And I go back to my techniques of solving quadratics. Change this to 36 really quick. And to solve quadratics, I know that I need to get everything to one side. So I'm going to subtract 36 over to get me 0 equaling x squared minus 9x minus 36. We can use completing the square quadratic formula. We could even graph it if we want. But in this case, let's just do it algebraically. Let's actually factor this. So I'm going to find all my factors of 36, and I stumble across 3 and 12. Those both multiply to 36. I want them to add to a negative 9, but multiply to a negative 36. So the signs I want are negative 12 and positive 3. And then we can factor them using that. So now I have x plus 3 and x minus 12. And I want the value of x, so I'm going to solve. X plus 3 equals 0 is going to give me x equals negative 3. And then the x minus 12, that's going to come out to x equals 12. Before we say we're done, we actually need to scroll back up to make sure that both of these answers work. Remember, in logarithms, we have domain restrictions where you have to be bigger than 0 inside of the log. We looked at that when we graphed them. We always had asymptotes in there. So I'm going to scroll back up, and I'm going to look at negative 3 first. If I plug a negative 3 into this side, that doesn't look so good, nor does it look so good over there. I end up negative in both logarithms. Again, you can test it, but it's going to spit out an error at you. So we know right off the bat that we do not want negative 3. If I look at 12, well, log base 6 of 12, that's positive. That's good. And log base 6 of 12 minus 9, well, 12 minus 9 is 3. That's also positive. So there's the value that I'm looking for. That's the only one that makes this thing true. It's positive on the inside, and it gets both sides equal to each other. We're going to do one more. We're going to look at 4a. 4b is pretty much the same as the one that we just did. So we're going to look at 4a down here. This one's going to use a couple properties. We're going to use the one from up above again, and we're going to use the one that has the exponent in it. So looking at the left side, I see this 2 out front. That 2 is actually the exponent on x squared. So we're going to say log base 7 of x squared now equals, separated by addition, becomes multiplication, log base 7 of 27 times 3. We'll do that quick math, that's 81. Log base 7 of x squared now equals log base 7 of 81. This one's a little different. This one's got 2 logs on each side with the same base. If I have 2 logs on each side with the same base, those don't really matter anymore. So we're going to say we want to get rid of them. And now I'm just dealing with where does x squared equal 81. Be careful though, to solve it, you have to take a square root, but when you take a square root, you get x equals, my marker just, we're going to get x equals positive. Well, it's not letting me write now. But when I solve this, I get x equals positive and negative 9. And when I get that answer, I want the actual positive value out of it. So we're going to say that x equals, oh, there we go, x equals 9 or negative 9. We want the positive value again, because again, it's got to stay positive on the inside. And then 4b is pretty much the same as the one that we did from up above. So I'd let you try that one.